Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is infrared spectroscopy as per USP 197K. Let us understand the infrared frequency. The importance of electromagnetic radiation was discussed in earlier videos also. However, today's topic is restricted to the infrared range of electromagnetic radiation. The actual infrared range is between 780 nanometers to 1 million nanometers. This you can see in the picture. The conversion between nanometers and frequency is a simple calculation. 10 million divided by nanometers will give you frequency in centimeter minus, and 10 million divided by frequency will give you nanometers. It is a simple calculation. But the frequency of interest for analytical purposes is between 650 centimeter minus and 3800 centimeter minus. It is in the far infrared and mid infrared range. See the picture. The energy of the electromagnetic radiation decreases with increase in the wavelength. Lower the wavelength, more the energy, and the energy can penetrate deep into the molecule. Higher the wavelength, lower the energy, and can only influence the peripherals of the molecule. This particular aspect has to be understood well. If you understand the story of the electromagnetic radiation in total, you will be really thrilled. In this infrared range, the electromagnetic energy will only be able to vibrate the atoms of the molecule in radial, in symmetric and asymmetric stretching, latitudinal, that is scissoring and rocking, and longitudinal, wagging and twisting directions. Let us see some of the important precautions to be observed for infrared spectroscopy. The gratings prism used for IR instrument uses cesium bromide, cesium iodide, potassium bromide, and potassium chloride in many instruments. The alkyl halides only are transparent to infrared radiation. They include cesium bromide, cesium iodide, potassium bromide, potassium chloride, etc. All the above salts are moisture sensitive. Traces of moisture can blur the optical path and gets damaged very fast. Since the alkyl halides are salts and are very sensitive for attack by any accidental moisture. So it is very important that the entire IR instrument is maintained dry, free from any such attack. To protect the gratings, prisms, it is necessary to use desiccants like silica gel in the pathway of the prism, beam splitter, sample compartment, etc. The best method is to place silica gel bags in the pathways of the light transmission to protect the key items of the instrument. The silica gel should be of self-indicating. You get large crystals with the blue color. Since they turn pink on exposure to moisture, it is easy to identify whether or not it is active. It is also necessary to monitor that the desiccant is active. This can be done by checking the silica gel bags every day and reactivate the silica gel when it turns pink. Reactivation is done by drying the silica gel at about 120 degrees Celsius overnight. But make sure that it is cooled in a desiccator to room temperature before reloading into the bags. See, this is a simple schematic of the basic of the instrument. It contains a source lamp for infrared range. Generally, nest glower is one of the sources for IR range. There are beam splitter, detector, processor, etc. All these items are very sensitive for moisture attack. So you have to be really careful to see that the equipment is protected well. Earlier, there was only simple infrared equipment. It is replaced with a faster version called FTIR. It is Fourier transform infrared. To make it simpler, let us understand that it can give more accurate scan at much less time. IR takes single spectrum, whereas FTIR uses an interferometer and takes a number of scans. IR uses monochromatic light, whereas FTIR uses polychromatic light. FTIR scans up to 50 times in a minute and giving better resolution. In FTIR, all analytes can be identified with a single measurement and the interferences are resolved. FTIR is a faster technique than IR. It is like an automated system when compared to a manual system. Let us see the procedure. Ensure that the equipment is kept away from the source of moisture, water, that means keep it in a dry place. As explained in earlier slide, it is absolutely necessary to keep the instrument in a clean and dry place away from any water source. Make sure that there is no water tap or a sink in the nearby vicinity. Switch on the instrument and allow it to warm up for 10 minutes. Set the resolution at 2 cm minus and measurement mode % transmission. IR spectroscopy is an instrumental method used to measure the absorption of electromagnetic radiation over the wave number range between 4000 and 400 centimeter minus. This is corresponding to a wave number between 2.5 and 25 mm. Unless otherwise specified in a monograph or other validated procedure, the region from 3800 to 650 centimeter minus, which is corresponding to a wavelength of 2.6 and 15 mm, should be used to ensure compliance with the monograph specifications for IR absorption. Generally, the scan would be between 4000 and 400 centimeters. But the range required is between 650 and 3800 centimeter minus for routine use. Let us see how the wave number accuracy is calibrated. Each functional group of the molecule rotates or vibrates specifically at a particular wave number. So it is important to calibrate the wave number accuracy for accurate scans. The most commonly used wave number standard for IR spectrophotometry is an approximately 35 micron thick matte finish polystyrene film. The spectrum of such a film has several sharp bands at 3060 centimeter minus, 2849.5 centimeter minus, 1942.9 centimeter minus, 1601.2 centimeter minus, 1583 centimeter minus, 1154.5 centimeter minus and 1028.3 centimeter minus. The most frequently chosen band for wave number accuracy determination is located at 1601.2 centimeter minus. The acceptable tolerance for the measured wave number is plus or minus 1 centimeter minus. Let us see the prescription under USP 197K. In this, K represents the first letter of the potassium bromide K. Certain powdered alkali halides such as potassium bromide, potassium chloride, cesium iodide under high pressure and can be formed into self-supporting discs that are transparent to IR radiation. Here, use always the analytical grade reagent for potassium chloride or potassium bromide for better results. It should be pure and dry. Then you get a nice transparent disc. The disc transmission must be at least 60% for a good scan. If the disc is clear, you are sure to get more than 60%. For opaque disc, you get very poor scan. You have to remember this. The alkyl halide most commonly used is powdered, dry, high pure potassium bromide, which is transparent to IR radiation above 400 centimeter minus. Commercial presses and dies in a range of diameters, generally 13 mm, are available for the preparation of alkali halide and similar discs. While using the die and press assembly, make sure that you close the protective cover of the press before applying the pressure for formation of the disc. Any mismatch in fixing the die and punch before applying the pressure can injure the operator seriously. To avoid such things, make sure that the protective shield of the assembly is closed well. See this example of potassium bromide disc, a clean disc, a transparent disc. See the prescription under USP 197M. Here also M represents the mineral oil mulls. You can see that M. The procedure to prepare a mull is to place 10 to 20 milligrams of the sample into an agate mortar and then grind the sample to a fine particle size powder using a vigorous rotary motion of the pestle. A small drop of the mulling agent is added to the mortar. Rotary motion of the pestle is used to mix the components into a uniform paste which is transferred to the center of a clean IR transparent window. Example, potassium bromide, sodium chloride, silver bromide or cesium iodide. A second matching window is placed on the top of the mull and the mull is squeezed to form a thin translucent film that is free from bubbles. The picture in the next slide will talk more than the verbal description. The mortar and pestle assembly for mull preparation is like this. The required amounts of the mull and the material are placed in this and made into a thin paste. See the example mull disc. The paste is placed in the center of the disc and exactly the matching cell will be placed on this and squeezed in between so that there are no air bubbles. Let us see the prescriptions for 197F and 197S. The reference 197F in a monograph signifies that the substance under examination is suspended neat. between suitable, for example, sodium chloride or potassium bromide plates. The reference 197S signifies that a solution of designated concentration is prepared in the solvent specified in the individual monograph, and the solution is examined in 0.1 mm cells unless a different cell path length is specified in the individual monograph. The USP 197F and USP 197S provide procedure IR scans for neat and a solution. See how the neat liquid or solution discs appear. See, in this example, the neat liquid or a solution is placed on this disc, and the second matched disc will be squeezed on that, and make sure that there are no air bubbles in that. Let us see the advanced technique of attenuated total reflectance ATR works. Attenuated total reflectance spectroscopy works on the optical phenomenon of radiation passing through a medium of high refractive index at a certain angle of incidence, entirely reflected internally at a boundary in contact with the material of lower refractive index. The sample under examination should be placed in close contact with the internal reflection element, that is IRE, such as diamond, germanium, zinc selenide, or other suitable material of high refractive index. Close and uniform contact between the substance and the whole crystal surface is necessary by applying pressure in the case of solid samples, or by dissolving the substance in an appropriate solvent and then covering the IRE with the solution and evaporating to dryness. In this technique, the sample is used without any support of KBr pellet. A small amount of sample is placed in close contact with the IRE with a high refractive index. This is very useful to take a scan of polyethylene bags to check for compliance to EP 3.1.3 or USP 661.1. Let us see how the IR cells are maintained well. Since the IR cells are very sensitive to moisture content, they have to be stored in a dry box, preferable with a permeable bag of active silica gel. This was discussed in earlier slides also. It is repeated here because of its importance to have such dry conditions always. For cleaning the cells, chamois leather. It cleans the IR cells free from any traces of contaminants or moisture. This is a very smooth leather which is used for cleaning of IR cells. Never use tissue papers to clean them. Tissue paper can cause scratches on the cells and damage them. It will have adverse impact on the IR scans. Make sure that the cells are totally transparent without any breakages. See these examples of the cells. This is an excellent, clear, transparent disc. Never use cloudy, defective areas, scratched or chipped cells for any IR scans. For scanning of liquids and solutions in IR range, there are transmission cells. Let us see how they work. For the examination of liquids and solution samples, transmission cell assemblies that comprises a window pair spacer, filling ports, and a holder are available commercially in both macro and micro sample configurations. For laboratory applications, spacers typically are formed from the lead that means tetrafluoroethylene or polyethylene tetraphthalate and can be supplied depending on the spacer materials. They are available in standard thickness of path lengths from approximately 0.6 mm to 1 mm or even larger. Let us see the examples of liquid transmission cells. See, there are two blocks. In between, the cell with 0.6 mm or 1 mm is fixed and the liquid is passed through the one hole, and when it overflows to the other hole, it will be sealed and you have 0.6 or 1 mm thickness of the sample for IR scan. Other references include test using a potassium bromide, that is USP 197K. So as told earlier, you have to remember for potassium bromide, K is used as a suffix. Test using Mull preparation is USP 197M. Test using liquid cells is USP 197S and 197F. Test using attenuated total reflectance technique is USP 197A. In addition to the above, the other references are USP 197E for IR microscopic analysis and USP 197D for diffused reflection analysis. I hope that the intent of this section of infrared spectroscopy is understood well. Try to read and understand all the references made. You may refer EP 2.2.24 or IP, the Indian Pharmacopoeia 2.4.6 for more similar information. USP chapter 854 gives you more insight into the operation principles of the infrared spectroscopy. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.